Okay, in this little tutorial, I'm going to try to take you through the steps of creating a randomized test for each student in your class so that each student gets a different version of the test. I've got a spreadsheet here which I've saved with the name Random Solved by Factoring, and I've got some columns up here with identifying information for the students. I've got first name, last name, full name, ID number, and email address, and I'm hiding all that for right now. And so we just finished reviewing solving a quadratic by factoring, so I want to create some random problems to give them on a test. So problem number 1, I'm going to call this root 1, and problem number 1 root 2. It's not really roots, as you'll see in a second, but all I'm going to do is pick a random number between 1 and 9. And I'm going to copy that and paste it there, pick another random number between 1 and 9. And so the problem for question number 1 is going to be this: x squared. To get the squared symbol, you can hold down the Alt key and press 0178 and release. That gets you x squared. Then I'm going to do space and a plus sign, and then space, end quote, and my coefficient of x, I want to be the sum of those two random numbers, so that's going to be f2 plus g2, close parentheses, and open quote, our variable x, and then a space, and then a plus sign, and then another space, end quote, and then in parentheses the product of those two, so that's going to be f2 times g2, close parentheses, enter. So there's our random quadratic that is based on these two chosen numbers. So these aren't really the roots. This is really the quadratic x plus 9 and x plus 1. So I'm making sure that instead of choosing the b and the c randomly, I'm making sure that I'm giving them a quadratic that is factorable. So now I'm going to copy that and paste it all the way down, and now everybody's got a different problem 1. But all the numbers are positive and all the numbers are between 1 and 9. So some people will get slightly easier problems than others, like this one has really small numbers compared to this one. And some people will get a double root like this, but for the most part, they're all the same level of difficulty. I'm going to change one more thing about this. After the product, I'm going to do and quote space equal sign space 0 end quote, so that it looks like an equation. Copy, paste. So that's looking the way I want it to look. I'm going to save. And that's only one problem so far, but I'm going to save, and then I'm going to go open a brand new Word document. So I'm going to just start from scratch, and I'm going to go ahead and save this as in my folder for my IM3 class in Unit IM2 review. Okay, I'm going to save this as solve by factoring test merge. Solve by factoring test merge. And I'm going to call this something like IM3 quiz solve by factoring. And then I'm going to have a spot here for the student's name. And problem number 1 is going to say solve And then problem number 2 down here somewhere is going to say solve. And let's just make this a little bit prettier. Okay, so now I'm going to start a mail merge. Mailing, start mail merge, step-by-step wizard. I'm going to do letters, next. Use the current document, next. Browse for a list of students or a list of recipients. So I'm going to go back to the folder that I was just in, Unit IM2 Review, and I'm going to grab that Excel spreadsheet I was just working on. Hold on just a second. I need to close this or else it's not going to let me open it. So, quadratic random solve by factoring right there. It's going to ask me what sheet, and I'm going to use the stuff that's on sheet 1. And we got all that. And then we click on next. And then right here where the student is, I'm just going to insert their first name just so I don't put their full names on blast for the purposes of this lesson. And then for problem number 1, solve, space, I'm going to insert 1 problem. And now next, we see Angelina is getting this problem, Lillian's getting this problem, and every student is getting a different problem number 1. Okay, then when I'm ready to send this to the students, so there's a couple ways you can do this. If you click Finish and Merge, if we were in person, if we click Finish and Merge, I can print documents and it'll print a separate page for each student on the merge. But in distance learning, I'm going to click on Send Email Messages. And it's pretty vital that when you're sending email messages, you already have a column on the spreadsheet that has a title of email. So I'm going to send to the student's email. I'm going to send an email with a subject line of something like, here is your test. And I could take this Word document and embed it in the email, but I want my students to open this as a Word document. So I'm going to click here on Attachment, and it'll create one Word document for every student on the list. It'll create the Word document, and it'll send that student an email with the Word document as an attachment. So that's what we want to do. And if we hit OK, I'm not going to send the students their test right this second, but if I hit OK, then the emails will all be generated and sent. Before you hit OK, you need to make sure that you have Outlook open so that Word can communicate with Outlook. Okay, so now I'm going to click Previous, and I'm going to click Save, and I'm going to go back to opening my spreadsheet, and I'm going to create some more problems. So problem number 2, root 1, and problem number 2, root 2, and then copy and paste that. And I should have just copied and pasted that. So we've got problem 2, root 1, problem 2, root 2, and number 2 problem. And now what I'm going to do is I'm going to make these negative numbers between, negative numbers between 1 and 9. And this plus sign at the end I can leave alone, but the sum of these two is going to be negative. And I don't like the look of this goofy plus sign and then a negative 10. I don't like the look of that. So we're going to edit that in 2 ways. First of all, instead of saying I2 plus J2, which is the sum of those two random numbers, we're going to do the absolute value of I2 plus J2 so that I won't get that little negative sign. But the sum of those two numbers is negative, so I want this, instead of being a plus sign, to be a minus sign. And one final touch is that there's a way to make this negative sign look more like a subtraction sign instead of a little hyphen. So we're going to edit this part right here. We're going to take that out. We're going to hold down the Alt key and press 0150 release, and that gets us a little bit better looking subtraction sign. So copy and paste all the way down, and now we have two problems for every student. All right, and here comes problem 3. 3 root 1 and 3 root 2 and 3 problem. So now I want one of the roots to be positive and the other one to be negative. So we're going to have to do a little bit of fancy footwork here, because sometimes these two numbers, well, they're always going to multiply to make a negative number. So this minus sign that I had here, I need this to be a minus sign here, 100%. And then I don't want a minus of negative 18. I want the absolute value of that. So that looks good, but the problem is sometimes this middle number is going to be negative, and sometimes, like in this case, that middle number is going to be positive. So we're going to need an if statement to decide what symbol to put there. So I still want the absolute value of that sum, because I don't want that little negative sign attached when it's a negative number. But now I need an if statement in the place of where this subtraction sign goes. So I'm going to put a quote there and an ampersand and an if, and I'm going to come over here a little bit and then do another ampersand. So, and then we need a little space here after the sign, and then right here is my if statement. So x squared space, and then this if statement that's going to determine if we're going to do a plus sign or a negative sign, and then another space, and then the coefficient of x. So if the sum of L2 plus M2 is less than 0, then give me that special negative sign. Otherwise, give me a plus sign. And this will handle almost every case. You'll see there's going to be one glitch here. But see, now we got a positive 8 with a negative 6, and that gives us a positive 2 here. And a 3 with a negative 1, that gives us a positive 2. But now we got a 2 with a negative 9, so that gives us a negative 7. So that appears to be all working swell. There's just one small issue. The one small issue is, what do we do if this is a 0? So if the two roots are the same, then we don't want to print any of that stuff that's in the middle. And with a big class like this, you're going to have a roughly 1 out of every 9 problems, just by chance, that will have that 0. So we've got to edit this some more. This gets a little bit codey, but we got to edit this a little bit more so that when the middle coefficient is 0, we don't display any of that stuff. So one more, I'm going to wrap all of this up in an if. So, sorry, I want to go up here to the top. All right, so after the space that's after the x squared, we want to say this. If L2 is equal, no, if L2 plus M2 equals 0, then we don't want to print anything. Otherwise, we will do this whole other if statement that chooses between the plus sign and the minus sign, and does the space, and does the absolute value of the sum, and does the x. So all of that up to the x, close that, close parentheses, ampersand, and quote. So let me hit enter and come over here a little bit more. I need to freeze this so it doesn't scroll off. Okay, so I want you to see this whole formula. So if L2 plus M2 is 0, then we're going to print nothing. So it's just going to be x squared and then a space. Otherwise, if it's negative, we're going to do the negative sign. And if it's not negative, we're going to do the positive sign. But we're also going to do the space after that. And the absolute value of the sum of those two, which is the coefficient of x. And then we're going to close. I need one more space in here somewhere. I need a space after that x. And I need to delete this space over here. So if the sum of those two is not 0, we're going to print either a negative sign or a plus sign, and then a space, and then the absolute value of the sum, and then x, and then space. But if the sum is 0, we're not going to print any of that, and then we're just going to print the minus sign, and then the absolute value of the product. Hit enter. And here's where we see if the magic happens. Copy and all the way down paste. And this is what we're looking for right here. So when those two added up to 0, we don't print anything related to the x term. And let's scroll up. Here's another one. Those two added up to 0. We don't print anything related to the x term. And here's another one right here. Now, there's one other thing that might be bugging some people, and that is when these two coefficients add up to 1, or if they add up, let's see if I have a negative 1 here somewhere. If they add up to 1 or they add up to negative 1, let me try this. See if I can find a negative 1. There we go. If they add up to 1 or they add up to negative 1, we probably shouldn't print the 1. So one other alteration we need to make to that formula. Right here, where I'm printing the absolute value of the sum of those two numbers, what we should say is this. Instead of just printing the absolute value of those two numbers, we should say if the absolute value of the sum of those two numbers is 1, then we're not going to print any number. Otherwise, we're going to print the absolute value of the sum of those two numbers. I know that seems a little bit redundant, but that's what we want to say there. So if the absolute value of the sum is 1, that means the sum was either 1 or negative 1, then we're going to print nothing in front of the x. Otherwise, we'll print the absolute value of the sum in front of the x. So we're going to copy that and paste all the way down. So here we have an example right here with a 9 and a negative 8. We've just printed the x without a 1. Here we got a 3 and a negative 4, so we printed a negative x without the 1. And there's another negative x without the 1. And our not perfect, but our difference of squares is working out fine. There's another negative x without the 1. There's a positive x without the 1. So all of that appears to be going really well. So I like the way that one went so well that I think I'm going to just copy and paste that for my fourth question. So problem 4, root 1, problem 4, root 2, problem 4, problem. Copy, paste all the way down. So now I have 4 problems, and I'm kind of liking the way this is looking. Now, for problem 5, I want to do something a little bit more extravagant. So for problem 5, I'm going to do a 5 coefficient 1, a 5 coefficient 2, a 5 root 1, and a 5 root 2, and a 5 problem. Okay, so now what I want to do is I want to pick 2 numbers for each factor. I want to be able to have factors that look like 2x plus 3 and 3x minus 4, for example. But to keep this kind of simple, I'm going to write a rand between statement, but I'm going to make sure that this first coefficient is always 2. And here I'm going to write a rand between statement, but this coefficient is always going to be 1 for now. I'm going to change that up in a little bit. This can still be any number from 1 to 9 for now. And this can be any number from 1 to 9. And I'm going to copy and paste this over here, but this needs a lot of work because, let me open up a Word document right quick. So what I'm trying to represent here is the equivalent of 2x plus 6 times 1x plus 1. So because of the foiling and the coefficient of x in the parenthesis, possibly both coefficients of x, I need to make this quite a bit more elaborate. So instead of t2 plus u2, it's not just the sum of those two, it's the sum of t2 times the coefficient of x in the second parenthesis and u2 times the coefficient of x in the first parenthesis. So all of these got to become t2 times s2, u2 times r2 because of the way we're foiling. t2 times s2, u2 times r2. t2 times s2, u2 times r2, t2 times u2 at the end, that's fine. So that's getting us 16x. We've got 2x times 5, which is 10x, 1 times 6, which is 6x. There's our 16x, so that's all fine. We're making everything positive, so we're going to put a plus sign there. So this is all going okay, except for one thing. If you look at this, oh wait, I need also this coefficient of x squared has to be r2 times s2. Okay, so now this is the situation that I'm trying to fix because this is just my personal preference. If you want to give kids factors that have a common factor, that's fine. But I would rather not have this parenthesis here have that 2 in common. So I'm going to have to be a little bit more sneaky about how I choose that random number for the root. By the way, 2x times 1x is 2x squared. 2x times 5x is 10x. 6 times 1x is 6x. And 6 times 5 is 30. So 2x squared plus 16x plus 30. So our display is correct. But I don't like this 6 having something in common with the 2. So instead of just picking a random number, I'm going to do a nested switch. So I'm going to do my first switch based on the coefficient in R2. And if that is a 2, then what I want to return is a switch. I'm going to put a question mark here first. A switch where my first possible number is a 1, my second possible number is a 3, my third possible number is a 5, my fourth possible number is a 7, my fifth possible number is a 9. So I want to be able to choose a 1 or a 3 or a 5 or a 7 or a 9. So I've got 5 possibilities there. So I'm going to pick a rand between 1 and 5. And then this is going to end there. So now root 1 is being chosen randomly, but it's always choosing an odd number because this coefficient here is 2. Now, what if I want this coefficient to possibly be 3? I have to add another case to my switch over here. So all of this that I was doing if R2 is 2, copy. I need to do that all again if R2 is a 3. So now if R2 is a 3, my first choice for this root is a 1. My second choice is a 2. My third choice, it can't be a 3, so it's going to be, my third choice is going to be a 4. My fourth choice is going to be a 5. My fifth choice is going to be a 7. Notice I'm skipping 6. My sixth choice is going to be an 8. And I can't have a 9, so I'm going to be done right there. So now I have 1, 2, 3, 4, 5, 6 possibilities. So this is going to be rand between 1 and 6. So notice if this is a 2, this is something that does not have anything in common with a 2. If this is a 3, this is something that does not have anything in common with a 3, which could be 1, could be 5, could be 4. So notice we're never going to get 2 numbers here for the coefficient of our first factor and the root of our first factor. We're never going to get 2 numbers there that have anything in common. Okay, let's take this one step further. Let's allow this to be a 1 or a 2 or a 3 or a 4. 2 or a 3 or a 4. So now I need to add one more thing to my switch statement. Copy all of that, comma, bam. So if that root, if the coefficient is a 4, then my first choice is a 1. My second choice is not going to be a 2 because then the 2 would have something in common with the 4. So my second choice has to go to a 3. My third choice can't be a 4, so it's got to be a 5. My fourth choice can't be a 6, so it's got to be a 7. My fifth choice can't be an 8, so it's got to be a 9. And therefore, I'm going to have no sixth choice, which means I need to make this a random number from 1 to 5. So when this coefficient in R2 is a 4, we're going to choose either a 1 or a 3 or a 5 or a 7 or a 9 for our root. So notice that's a 4, that's a 9. That's a 3, that's a 2. That's a 4, that's a 7. So this number here, let me highlight, this number here and this number here should never have anything in common. They should never have a common factor. That's what I'm doing with the nested switch statements. I know that's a little bit advanced, but let me take this one step further. Now let's make it a random number between 2 and 5 and add yet one more choice to this switch. So if the leading coefficient is a 5, then we can have for the constant or for the root any number besides 5. So the first choice will be a 1, the second choice will be a 2, the third choice will be a 3, the fourth choice will be a 4, the fifth choice will be a 6 because we're skipping 5, and then the sixth choice will be a 7, and then the seventh choice will be an 8, and the eighth choice will be a 9. So now let's see if we get a 5 there. We'll get some number here, any number other than 5. So again, I'm just looking for these two numbers highlighted in yellow to not have, oops, I didn't want to delete that, to not have anything in common. And if I'm happy that I've got that working, then let's choose this coefficient in the same way. And let's choose this root in the same way. We don't need all of that yellow anymore. So now the leading coefficient, okay, so this problem that we have just generated right here is 3x plus 7 and 2x plus 3. So the 3x times 2x is 6x squared. The 3x times 3 is 9x. The 7 times 2x is 14x. The 7 times 3 is 21. And the 9x and the 14x in the middle makes our 23x. So that problem is working out beautifully. So this is what I wanted for problem 5. And now that I got that looking the way I want, I'm going to copy this and paste all the way down. Okay, so I'm very happy with the way that's working. Now, one more problem on this quiz. We're going to do all of that stuff exactly the same. Problem 6, coefficient 1. Problem 6, coefficient 2. Problem 6, root 1. Problem 6, root 2. Of course, I know that's not really a root. I could call it the constant term or whatever. And then this is going to be problem 6 problem. Now, I want one of those roots to be negative. So I'm going to come up all the way to the beginning of that switch statement and put a negative sign. So notice that the code we already wrote 3 problems ago is handling the display of that negative sign in the middle instead of a positive sign. Oh, but I need a negative sign at the end, because if one of these is positive and one of these is negative, I got to have a negative sign at the end. So let me just copy that pretty looking negative sign and paste it right there. Okay, there we go. So I'm looking at the middle term. Sometimes it's positive, sometimes it's negative. So that's behavior. Oh, there we go. We got 5x plus 6 and 5x minus 6. So we got a difference of squares. That's beautiful. Our code handled leaving out the x term in the middle. And there's one. We got a 3 times -5, which is -15, and a 2 times 7, which is 14. So that made a -1 in the middle. So that all looks sweet. Now we do all of this, copy and paste, and I think I'm ready to be done with this. So I'm going to save and close, and then I'm going to reopen. The Word doc where our test was, solved by factoring test merge. And so now we just got to do the rest of our problems. So we have a problem 1, a problem 2, a problem 3, problem 4, problem 5, and a problem 6. Trying to make this fit on one sheet of paper. Of course, once they add their work, it might not fit on one sheet of paper. But so they might add spaces in between these. This has 1, 2 spaces, 1, 2, bam, 1, 2, bam, 1, 2, bam, 1, 2, bam, 1, 2, bam. Okay, so now we come back over here to the Mailings tab, Start Mail Merge Step by Step, and we go to the next step, and we click on More Items. Whoops, let me put my cursor right here where I want problem 2. More Items, problem 2, bam, close. Put my cursor here. More Items, problem 3, bam, cursor here. More Items, problem 4, bam, cursor here. More Items, problem 5, bam, and cursor here. More Items, problem 6. Close. Preview the letters. Let me zoom out a little bit so I can see the beauty of everything changing. So I go through my recipient list, and as you can see, every student is getting their own set of randomly chosen problems. So this is exactly how I want it to look. Okay, I'm going to save right there, and I'm going to close, and I'm going to do one more thing with that Excel spreadsheet. I'm going to create another sheet. I already have the student's vital information on sheet 2, which I don't want to display. I'm going to create one more sheet, and what I'm going to do is I'm going to highlight all of this information. Hold on, I want to hide B, C, D, and E so you guys can't see the vital information. Okay, bam. So go back to this sheet, highlight everything, copy, and then come over to this other sheet, and we're going to just paste values. So I do that with the keyboard shortcut, which is Alt-E-S, and then arrow down to values, and then hit enter. Now the reason why I'm doing this is that every time I open up this spreadsheet, every time I type anything in any square, all of the randomization is redone. So I wanted everything to be random, but now that I've randomly decided on their problems, I want to freeze those problems in time, so to speak. Okay, and the reason why I want to freeze those problems in time is because now I can come over here and create my key. So since we've got 33 unique tests, every one of them has to have their own key. So let me zoom in on this a little bit so you can see what I'm doing for the key. Probably not going to do the whole thing in the interest of time, but let's freeze this. Okay, so my key for problem 1, the answers for x are just going to be the negatives of these two roots, which are in f and g. So my key for problem 1 is going to be, quote, x space equals space, end quote, ampersand, parentheses, the negative of f2, close parentheses, ampersand, quote, comma, space, x space equals space, end quote, ampersand, parentheses, negative of g2, close parentheses, bam. So there's my key for this problem, for this student. And notice as I copy and paste that key all the way down, now I have a key for every student's problem. And notice the issue is that if I copy and paste on the randomized sheet over here, all the problems will change. So I want to be able to mess around with the answer key after I've sent all the students their test, or after I've printed out all of the tests. So the 2 key is going to look very similar to this. So I'm going to copy paste, but then I got to see where those roots are for 2. So for 2, they're both negative, but they're in I and J. So the key for problem 2 is going to be the negative of what's in I and the negative of what's in J. And notice in this key over here, it doesn't bother me if I'm the only one looking at it if we have those little puny negative signs. That doesn't bother me at all. I don't like that in a document I'm sending out to the students, but it doesn't bother me at all. And then for problem 3, the key is going to be very similar, except the quote-unquote roots for problem 3 are in L and M. So I want this to be the negative of what L is and the negative of what M is. So that's my answer key for problem 3. And then these other problems are going to have answers that are fractions. So problem 4 is the same as problem 3. That's O and P. Problem 4, the roots are in O and P. So change this to an O and change this to a P. And we have that. Copy, paste. And 5 key, this is where it's going to get a little bit interesting. So for 5, we're going to have the negative of the root, which is in T2, divided by the coefficient that's in R2. So the negative of T2 divided by R2, the negative of T2 and ampersand, quote, division sign, end quote, ampersand, R2. So we have a fraction. Oh, doesn't like that. Oh, doesn't like that because of Q. And then we're going to be doing the negative of U2, ampersand, quote, division sign, end quote, ampersand, S2. So our answers look like fractions And I don't think our fractions can be reduced. Let's see, some of them are improper, but they shouldn't be able to be reduced because of the way we chose the coefficients and the roots. We made it so that they didn't have anything in common. So none of these fractions should be reducible. And again, because I'm the only one looking at the key, I don't care if those fractions look like vertical fractions or this kind of old school fraction or not. And then one last thing, 6 key. And then we're going to copy this, but 6 is the negative of y2 divided by w2, and then the negative of z2 divided by x2. So now I have an answer key for everyone's test. And yeah, there's a couple things I could do here to make it more readable. I could, shade every other column or something like that to make it a little bit more readable. Sometimes I like to shrink the spreadsheet so much that I can only see one line at a time, like that. So now I'm grading Angelina's paper. Here's the key. And then I go to the next answer online. I go to Lillian's paper, and here's the key. And I go to Robert's paper, and here's the key. So now here's the slight problem. Because I've got all of these static problems are in sheet 3, and I've got my key in sheet 3. I do not want the Word document to be looking at the randomization in sheet 1. I want the Word document to be looking at sheet 3. So this is saved. We go back to the Word document. And we click on the Mailings tab, and we do step-by-step merge. And we're going to select a different list now. Bam. So now we're going to go up to the folder that's in. We're going to click on Random Solve by Factoring again. But now we're going to say we want the data in sheet 3. Which is all of my students, and then we say write your letter, and then preview your letters, and let me scroll a little bit so I can see all the problems. And there's everybody's randomized test. And now we've got this finished product, so we're ready to hit finish and merge. Send email messages. Remember, you got to have an email field in an email column in the Excel spreadsheet. I'm going to say for the subject line of the email something like start your test, see attached. And instead of HTML format, we're going to do this as an attachment. And then as soon as you click OK, remember you got to have Outlook open during this process. As soon as you hit OK, then all of the emails are generated via Outlook. Okay, I'm not ready to print them right now because it's midnight, but when I get ready to give my students the test, I'll hit OK, and they will all get an email with an attachment of their individualized test. So I hope that was somewhat informative for some people, and I'll have some other videos on how to do this with a little bit more elaborate test and how to do it with multiple choice tests and whatnot.